Alright guys, happy Tuesday. I know that sounds kind of lame, but one day into school already. We are on the second day, Tuesday. We are going to be reviewing a couple things. We are going to be reviewing trig. We're going to be reviewing special right triangles. And then we are going to be combining trigonometry with special right triangles. So let's go over trig real quick. Remember when we learned trig, I talked to you about SOHCAHTOA. And then remember SOHCAHTOA, as in your notes, the sine was opposite over hypotenuse. Cosine was adjacent over hypotenuse. Tangent was opposite over adjacent. And then all you needed to do with these was, for in the very beginning, you just had to write them as ratios, and that's all we're doing today. A ratio is just a fraction. And remember, you had some questions like this. Let's say like this is A, this is B, and this is C. And let's say this is X, this is side Y, and this is side Z. All right, so I asked you, for example, what is sine of A? What is cosine of A? What is tangent of A? And then I asked, what is sine of B? Cosine of B. Tangent of B. And then all you guys had to do, when you guys got the hang of it, you're like, oh wait, this is really easy. Sine of angle A is, sine is opposite over hypotenuse, which would be Y over Z. Cosine is adjacent over hypotenuse, which is X over Z. Tangent is opposite over adjacent, Y over X. And then, if we're going from sine of B, sine, remember, once again, is opposite over hypotenuse, X over Z. Cosine is adjacent, which is Y over Z. And tangent is opposite over adjacent, which is X over Y. And then you just had to leave it as a super, super simple fraction, and that's it. Okay. Then when we got into a little more detailed stuff about trig, you had to actually write these as numerical fractions. So look at the example that I give you. A, B, C, and I say if your hypotenuse is 50, this is 30, and this is 40. All right, and then I ask you to do this. I ask you to write sine, cosine, and tangent of angle A. So here's angle A. Sine is 40 over 50. Cosine of angle A is equal to 30 over 50. Tangent of angle A is equal to 40 over 30. And then on your notes, I underline, I say always reduce, meaning if you can, 40 over 50 becomes 4/5. 30 over 50 becomes 3/5. 40 over 30 becomes 4/3. And then there's your reduced fraction. Super simple. We are going to carry this concept now into trigonometry. But before I go into this, I have to go over something called rationalizing the denominator. And what that means is this. Let's say we have a fraction of 2 over square root 3. In mathematics, you cannot have a root as your denominator. It's not considered simplified because it's an irrational number in your denominator. So in English, what that means in English is you have to get rid of root 3. You have to multiply. The way you get rid of a root is you multiply it by itself, and you'll see why in a second, but check this out. In order for me to get rid of the root 3, I'm going to multiply it by its same term. Because root 3 times root 3 is the square root of 9, and the square root of 9 is 3. But whatever I do on the bottom, I have to do on the top. Root 3 over root 3 has a value of 1. And conceptually, anytime you multiply a fraction times the same times 1, you get a different looking fraction, but it's technically the exact same fraction, just a different way of looking at it. For example, like 1/2 is the same thing as 5 over 10, which is a different form of 1/2. Same thing. Coming back to this, we have to simplify the root. So you multiply the bottom by this root to cancel out the root to get 3. But whatever you multiply the bottom by, you have to multiply the top by. The reason why we're multiplying the bottom by root 3, because this is a root 3. If this was a root 12, we'd multiply the bottom by root 12 and root 12. If this was the square root of 2, we would multiply by square root of 2 and square root of 2. Whatever the denominator is, that's what you're multiplying the top and the bottom by. Now look, root 3 times root 3 is square root of 9, square root of 9 is 3. But I have to multiply the top. 2 times root 3 is 2 root 3. So this, if you have a calculator, do this on your calculator. Do 2 times root 3, press equals, divided by 3. You are going to get the exact same answer as if you do this on a calculator. 2 divided by root 3. This is the same version of this. Believe it or not, this is the simplified version of this. The reason why it's simplified is because you cannot have a root in your denominator. And the reason why that's important is we're going to do some questions now. And some of the questions require you to do what we just did. And we'll get to that. We'll cross that path when we get to it in a second. Okay, so look at the notes. The notes says special right triangles are set up the same way with trig. You do the exact same thing. So let's do this. Let's look at this. You know, in a 30, 60 degree, 90 degree triangle, we're going to call this angle A. Your shortest leg is some number. Your longer leg is that number times root 3. And your hypotenuse is 2 times the size of your shortest leg. Okay, now what if I were to ask you, what is sine of angle A? A lot of people get confused and they say, I don't know what to do because we have variables, we don't have numbers. It doesn't matter. Sine of angle A. Sine of angle A is the same thing as, what is angle A in this specific example? It's 30 degrees. So if I say, what is sine of angle A, which the notes is asking you, it's asking you the same thing as, what is sine of 30 degrees? What is cosine of 30 degrees? What is tangent? Because in the notes I ask you, what is tangent of angle A equal to? Tangent of angle A is the same thing as, well, angle A is 30 degrees. So if I were to say, what is tangent of 30 degrees equal to? All right. Remember, so, ka, toa. Sine of 30 degrees. All right, so from this 30 degrees, this is what we're going off of right here. Sine of 30 degrees is opposite over hypotenuse. And remember, I told you, you always reduce. X over 2x reduces to 1 over 2. Okay, this is going to be important in a second. But let's continue on. What is cosine of 30? Well, cosine is adjacent x root 3 over hypotenuse, which is 2x. Remember, cosine of 30 degrees, cosine of 30 is adjacent over hypotenuse. And then reduce. These two x's cancel out to give me root 3 over 2. Then if I were to ask you, what is tangent of 30 degrees equal to? As a fraction, what's it equal to? Tangent of 30 is, remember, tangent is opposite x over adjacent, x root 3. Okay, now look, see this root 3? This root 3 cannot be in this denominator, so we have to multiply the top and the bottom by that special form of 1. Root 3 over root 3. Remember, x root 3 times root 3 is square root of 9. Square root of 9 is equal to 3. What is the square root of 9? 3 times that x is 3x. Once again, when you multiply the two roots that are the same, you're left with the number that's in the middle inside the root. And then x times root 3 is x root 3. X root 3. Okay, always reduce these two x's. Boom, they're gone. And you get tangent of 30 degrees is equal to root 3 over 3. Okay, now, if you have a calculator, what I want you to do is this. On your calculator, I want you to enter in sine, make sure it's in degrees, and press sine of 30. Sine of 30 degrees, and what does it spit you out? It should say 0.5, which is 1/2. See? 1/2. What is cosine of 30 degrees? Okay, cosine of 30 degrees is going to spit you out a number that's more or less equivalent to 0.86. Now what I want you to do in your calculator is this. Do root 3 divided by 2. Square root of 3, press equals, divide that by 2, and you get, boom. This answer gives you this because in a 30, 60, 90, if you do adjacent over hypotenuse, it's always going to reduce to this answer. Kind of a trip, strange. If we were in a normal classroom setting, I'd be able to break this down, walk you guys through a lot more examples, but hopefully you guys are getting this just with this picture. And the same with tangent 30. If you do tangent 30 on your calculator, you're going to get the same answer as square root of 3 divided by 3 would be. So what I'm going to do is this. I'm going to write this up here. Sine of 30 degrees is always equal to 1/2. Cosine of 30 degrees is always equal to root 3 over 2. Tangent of 30 degrees is always equal to root 3 over 3. Now, the reason why I'm writing this up here is because as we do these, you're going to see no matter what the triangle looks like, and this is the important thing to understand, no matter what the triangle looks like, it'll always simplify to this ratio. Let me show you. Let's look at the next example that I give you in red. Okay, here's angle A, and once again, angle A, we're going to call this 30 degrees. It's not in the notes, but it's 30 degrees. This is 40, this is 80, and this is 40 root 3. Okay, now what I'm going to do is this. I'm going to also ask you, in the notes I say, what is sine of angle A? Angle A is 30 degrees. So what's sine of 30 degrees from this triangle? What is cosine of angle A, which is 30 degrees? In this triangle, even though it's totally different from the previous example, and what is tangent of angle A in this, what is tangent of 30 degrees in this triangle? Watch, everything works out to exactly the same. Sine of 30 degrees, so from the 30-degree angle, which is angle A, from this angle right here, opposite over hypotenuse. 40 over 80 reduces to 4 over 8, or look, sine of 30 degrees is always 1/2. Cosine of 30 degrees, which is adjacent, 40 root 3 over 80. 40 over 80 reduces to 1 over 2 root 3. 1 times root 3 is just root 3. This simplifies to root 3 over 2. See? It's already right there. And tangent, the same thing, is we have adjacent, or opposite, 40, over adjacent, 40 root 3. How do you get rid of this root 3? You multiply the top and the bottom by root 3. All right, and then continuing this is going to simplify to root 3 over 3, believe it or not. Watch. 40 times 40, root 3 times root 3 is root 9, and the square root of 9 is 3. 40 times 3 is 120. If I went a little fast, you can rewind the video. I just multiply these two roots to get root 9. Root 9 times 3, and root 9 is 3. 3 times 40 is 120. And then you have 40 root 3. Here, 40 times root 3 is 40 root 3. 40 over 120 reduces to 1 over 3. But You don't need that 1 there. With that root 3. It'll always give you the exact same answer, no matter what the triangle looks like. All right. Now, let's go over some more examples. I'm going to give you some 45, 45, 90-degree triangles. And just to let you know, look, sine of 30 degrees, let's do, what if I were to do sine of 60 degrees? Cosine of 60 degrees. Tangent of 60 degrees. Doing everything the exact same way. This is what happens. It's always a pattern with trig. Sine of 60 degrees, if you were to redo the triangles, instead of finding angle A, you'd find the other angle that we didn't find. Sine of 60 degrees is always equal to whatever cosine of 30 degrees is. Cosine of 60 degrees is always equal to what sine of 30 degrees is. And tangent of 60 degrees is this fraction flipped around. So if you were to do cosine of 60 degrees, watch. Let's take the last example. This was 40, this was 80, and this was, oh, this is supposed to be 40 root 3. The notes, I say 80 root 3. I'm sorry, this is supposed to be 40 root 3. Sorry for the confusion, anybody. This is supposed to be 40 root 3, not 80 root 3. Anyways, let's do this. Let's see if sine of 60 actually equals root 3 over 2. Sine of 60 degrees, which is opposite over adjacent. 40 root 3 over 80 reduces to root 3 over 2. See? It's kind of a trip how it always works like this. What is cosine of 60? Let's see if it equals 1/2. Cosine of 60 is adjacent over hypotenuse. 40 over 80 is 1/2. And what's tangent of 60? Tangent of 60 should be this flipped around, which is 3 over root 3, which you know you can't have 3 over root 3, so you multiply the top and the bottom by root 3 to get 3 root 3 over 3, because root 3 times root 3 is just 3. 3 root 3, simplifying to root 3 by itself. Tangent of 60 degrees is always equal to root 3. If that tripped you out right here, because this is, tangent of 60 degrees is always the opposite of tangent of 30 degrees. If that didn't make sense, well, let's look. What is tangent of 60? Tangent of 60 is opposite 40 root 3 over adjacent 40. Boom, those cancel out to get root 3. See? Okay. Now, what you're going to also notice with 45, 45, 90-degree triangles, everything will always simplify, just like with 30, 60, 90, everything will always simplify to the exact same answer. Watch. Let's take this first example. And this is a 45, 45, 90. If this is 10, remember this is half of that number, root 2. Half of that number, root 2. And this is A and C and B. All right, so let's find sine of A and sine of C. Cosine of A, cosine of C. Tangent of A, tangent of C. You're never going to find the trig ratios of the right angles. It's always going to be the other two angles. Okay, sine, let's start off with A. It's equal to opposite 5 root 2 over 2. But look, what is, let me go back. What is angle A and angle C? Angle A is, look, this is 45 degrees, this is 45 degrees, this is 90. So angle A is actually 45 degrees. What is angle C? Angle C is actually 45 degrees. So sine of A is going to give you the exact same answer as sine of C. Cosine of angle A is going to give you the exact same answer as cosine of angle C because they're both 45-degree angles. You can see how both of the sides are the same also. Tangent of angle A is going to give you the exact same answer as tangent of angle C, as you'll see. So sine of 45, which was A here, which is opposite over hypotenuse. 5 root 2 over 10 reduces to sine of 45 equals root 2 over 2. Let's see if we get root 2 over 2 for these four. What is sine of this 45 degrees? Or cosine? Adjacent over hypotenuse, which reduces to root 2 over 2. What's sine of this angle C, which is also 45 degrees, by the way? Opposite over hypotenuse. 5 root 2 over 2 reduces to root 2 over 2. Same with cosine. Cosine of 45 degrees is going to give you root 2 over 2. And then tangent. Opposite over adjacent. 5 root 2 over 5 root 2 is equal to 1. What's tangent of this angle? Opposite over adjacent equals 1. You're always going to get these two as answers, no matter what the triangles look like. I'll show you. So it says find the trig ratios of all three trig angles for A and C. I'm just going to do A because A is the same as C. They're both 45 degrees. So watch. This is 10. This is 5. Oh wait, I'm sorry. I already did that for that one. Going on to the second question. The second question. Okay. If this is a 45, 45, 90. If this is 9 root 2, the two bases are the same. 9 root 2, 9 root 2. Remember, this is whatever these two sides are, this is that same number times root 2. Remember, this is x, this is x root 2. 9 root 2 times root 2 is 9 root 4. And the square root of 4 is 2. So 9 times 2 is 18. What if they just gave you these two sides? Remember, if they give you your hypotenuse is just a number, each one of these is half of that number, root 2. See? It works out. Well, what? Let's do sine, cosine, and tangent of this angle right here, which is 45 degrees. You're going to see how you're going to get these two each time. Sine is 9 root 2 over 18, which reduces to root 2 over 2. Cosine is 9 root 2 over 18, which reduces to 2 over 2. Tangent is 9 root 2 over 9 root 2, which reduces to 1. Every single time. Let's do the very last question, and then we are done with this assignment. All right, so the very last question. Another right triangle. It's a 45, 45, 90 degree right triangle. And if this is 12 root 6, this is half of that root 2, half of that times root 2. So this is a number. This is half of that number times root 2. So we're going to do 12 root 6. We're going to take half of this and then multiply that answer by root 2. Remember, whatever this is half of it, root 2. So if this is 12 root 6, this is 6 root 6 times root 2. 6 root 6 times root 2 is going to give me 6 root 12. All right, and you can simplify this 6 root 12 if you want. That's fine. I'm just going to leave it as 6. Actually, I'll go ahead and simplify this. All right, so if I have square root of 12, I'm going to do square root of 4 times the square root of 3. Square root of 4 times the square root of 3 is going to be 2 root 3. 2 times 6 is 12 root 3. All right, well, let's see if this still works with the pattern. You should always simplify the root from here on out. x root 2. So 12 root 3, 12 root 3, 12 root 3 times root 2 gives you 12 root 6. All right, pattern works out. So let's find sine, cosine, tangent of this angle. Watch, it'll always simplify to these same answers. Tangent. Tangent is opposite over hypotenuse. Okay, these cancel out to give me square root of 3 over square root of 6. We're going to get root 2 over 2, simplified. Watch. You can't have a root in your denominator, so you have to multiply the top and the bottom by the root. This is going to give you square root of 18. This is going to give you 6, because square root of 6 times the square root of 6 is just 6. This doesn't look like this, because you have to simplify. Root 18. Remember, with simplifying square roots, we can pull out a square root of 9 times the square root of 2. Square root of 9 is 3 times the square root of 2. So in your calculator, 3 root 2 is the same thing as the square root of 18. So instead of the square root of 18, I'm going to say 3 root 2 over 6. Now watch. 3 and 6 reduce to 1 and 2. Look, boom, root 2 over 2, root 2 over 2. Same thing. So for the questions today, you're going to be answering sine, cosine, and tangent for either 45 degrees or 45 degrees, 60 degrees, and 30-degree triangles given different triangles. You'll have to find the missing sides and find then the ratios.